Hey everyone, welcome back. We're in grade 6, unit 7. This is lesson 6, and we're talking about different ways that we can describe ratios. So, today's lesson talks about mixing cups of sand. I'm not sure why a person would want to mix two different colors of sand. So, it tells us that Seth is making a sand mixture and he's mixing green and yellow sand. I don't know. Maybe you can figure out why a person would do that. I did actually look on Amazon to see about buying some colored sand to have it here, but it's kind of expensive, especially if you're just going to mix it then and do what with it? I don't know. So, if you know what a person does when they mix different colors of sand together, why they would do that, aside from just to do it because looks good and interesting, I guess maybe. Yeah, give me a comment on that. So I don't actually have sand here with me, but what I have instead is my sticky notes, and we're going to do the parts of the sticky notes like you maybe have seen me do before. So it tells us that Seth mixed 4 parts of green sand. So I'm just going to mix 1, 2, 3, 4 parts of green sand. So, wow, that looks really yellow. I don't know if that's going to work or if you're going to be able to tell the difference. Okay, well, let's see. So he has 4 parts of green sand, and he also has 3 parts of yellow sand. There it is. Now, oh yeah, it's really hard to tell the difference of those, isn't it? Let's see if I see what I can do about this to help you be able to see those differences better. Hold on, I'll be right back. Okay, I just outlined it with green and it's showing up better. So these are green, actually. Sorry about that, just not showing up very good. And these are yellow. So he has 4 parts green sand and 3 parts yellow sand. So first of all, we're just going to think about that in the way that we've been thinking about it quite often. How are we going to write the green to the yellow? Well, hopefully you're thinking of a few different ways. 4 greens, 2, 3 yellows. So we could write 4 2 with the word to, 4 to 3. How else could we write it? Hopefully you're thinking of 4 with a colon. 4, remember we read it 4 2 3. Can you think of another way? Hopefully you're thinking of the way it looks like a fraction. 4 2 3. So there's 3 different ways that we could compare the green to the yellow. Remember, what would happen to these numbers if we were comparing the yellow to the green? We'd have to flip them around, wouldn't we? If we're talking about the yellow to the green, remember the words have to match the number order, and the number order has to match the word order. So if we say, what is the ratio of sand of yellow sand to green sand? Then we'd have to say 3 to 4. If we say, which is the green sand to the yellow sand? Then we say 4 to 3. So that's important all the way through the lesson. So let's go on in just a second to another part. Okay, next they want us to think about the amount of the sand compared to the total mixture. So when they say mixture or total mixture, they mean we poured all this sand together, and what is the parts compared to the whole thing we put together? So if you're looking on page 353, it says there are blank parts of green sand in blank parts total mixture. So, how many parts are there in the whole thing when we put them all together? Well, it's not 4 and it's not 3. It's 7. There's 7 parts total. So the total mixture has 7 parts to it. So, how many parts out of the total is green? It's 4 to 7. We have 4 greens out of the whole 7 parts. So 4 parts are green out of a total of 7 parts. So let's pause and write that. How do we write 4 to 7? 4, the word to, 4 to 7. 4 colon 7, and then of course 4 out of 7 as a fraction. So for every 7 parts of the mixture, there are 4 parts of green sand. Okay, so hopefully that was kind of a review for you, thinking back a little bit to Unit 1 and thinking back a little bit to what we've done earlier on in this unit. Now, this part, I'm going to tell you, it gets tricky. This is a hard thing to understand, and you'll get it, but you have to stick with it, and you might have to try a few times, and that's okay, because if it's worth learning, it's worth learning. And it might take you a little bit of time, and that's okay. So at any time you can stop. If you get confused, you can stop. You can go back and watch the video again. You can take a little break. I do very much encourage you to have materials, just like I always do, they can really help you. So, all right, let's get started. What it wants us to do now is think about changing what's the whole thing. Now, this is kind of mind blown. And if you think about, we've done this when we used base 10 blocks. We changed them. We said when we started working with decimals, I said, okay, we're going to change the size of the whole thing. It's not going to be that teeny tiny little cube anymore. Now the whole thing is going to be that big, what we usually think about this, the thousands cube. Now it's going to be the thousands cube. We're going to do the same thing here. So let's take a look at how we're doing it. The first part, I'm on page 354. The first part says the green sand is 1 cup. So all that together is 1 cup. So how much are each of those pieces if this whole group together, all the green sand all together, is 1 cup? Well, hopefully you're saying, well, if it's 1 cup, there's 4 of them, so they must each be 1/4. And you would be right, 1/4. So they're each 1/4. Now, remember, when we're talking about parts of something compared, we're always talking about equal parts. We have to remember that the word that we don't hear but is in there is equal. So these parts are all equal. 1/4 is equal to 1/4 is equal to 1/4 is equal to 1/4. But what about these? They're also equal. So whenever we're talking about a group of something and talking about a ratio of something, it always is equal parts. So these yellow ones are also 1/4 of a cup. So we have 4 1/4 cups of green in this mixture, 3 1/4 cups of yellow in this mixture. Now, the question then is also, how many total cups do we have? Well, we have 1. We told us green sand is 1, so there's 1. And 3 out of 4 pieces, 1/4 plus 1/4 plus 1/4 is 3/4. So our total, let me pause and write that. Okay, so our total mixture is 1 3/4 of a cup. There's 1 cup, it told us that. And then we figured out each was a fourth. And all the parts have to be equal. So these are also fourths. So we have 1 3/4 of a cup. Now, you might say, well, that wasn't so hard. I don't know what Miss Goobert was talking about. That actually wasn't all that hard. No, here's the hard part. We're going to change now the size of the whole thing. So this is 1. In this particular case, the amount of green sand was 1 cup. But look next door where it says, now the yellow sand is 1 cup. This is the hard thing. These aren't 1/4 anymore, because now they said, what if we told you that the yellow sand, all the yellow sand together, is 1 cup? How would that change everything? This is the tricky part. So all this together, these 3 together, equals 1. So there's 3 pieces to equal 1 whole. So each of these isn't a fourth, it's what? I hope you said it's a third now. So now this is now a third, a third, and a third. It's tricky because we're using the same diagram and everything looks the same. If we were actually measuring out sand each time, it would be a little easier to see. So if you get confused, can you figure out what I'm going to tell you to do? Get something to measure. Sugar would be awesome for this. So if your family would let you, if you have a big bag of sugar and your family would let you, this would be a great time to actually go and measure out. We need 1 cup of yellow sand, and now we need to divide it into 3 to actually measure this out. If this is giving you trouble, it would be a really great time to do that. Now, if these are each a third, what are the greens? Well, hopefully you're saying it has to be equal. All the parts in the thing, if we're talking about parts compared to like fractions and ratios too, they all have to be equal. So if each of these are a third, these are also a third. So how much green do we have? We have 1 plus 1/3 plus 1/3 plus 1/3. That is 1 whole and another third. So now the green is 1 and 1/3 cups. What about the whole thing? What about the total mixture? Well, it's 1 whole and another 1 whole and another third. So now it's 2 and a third. See why kids could get confused here? Because we're looking at exactly the same diagrams, exactly the same materials. That's hard to see. There you go. But we're calling them different things. Because the first one, we said it was the green that was 1, and we figured it out from there. The second one, we said it's the yellow that's 1, and we figured it out from there, and we're not done yet. We have 1 more. They also say, what if we told you that it's not the green or the yellow that's 1, it's the whole thing. We're making 1 recipe, 1 batch. This is 1 cup. All of this together, the total is 1 cup. What would the parts be? How many parts are there in the whole? There's 7. So these would be sevenths. 1 out of 7. What about the greens? 1 out of 7. So how much yellow sand is in the whole mix if the whole mix is 1 cup? Yellow sand is 3/7. How much is the green sand? 4/7. See how that's tricky? We did the same thing. You can see it. Here it is. We did. Okay, sorry about that. The computer just fell right off the stand where I have it. So that wasn't good. So sorry about that. Okay, we're back. So we're going to talk about for every 1 cup of green sand, how much yellow sand do we have? 3/4 of a cup, because it's 3 out of 4 pieces that makes the whole. But what about if we have 1 cup of yellow sand? For every 1 cup of yellow sand, how much green sand do we have? There's the whole and some extra. So we have 1 1/3 cups of green sand. And what about how much green sand and how much yellow sand do we have for every 1 cup of mixture? We have 3/7 and we have 4/7. Okay, now it wants us to name what we've just done here. It wants us to name that as a multiplicative comparison. Those are hard words. What does multiplicative sound like? I hope you hear the word kind of multiplication, right? As in sort of groups of or times is what we think of when we think of multiplicative. Comparison means how one is compared to the other. So try it. Look at number 16, and it says the amount of yellow sand is blank times the amount of green sand. The amount of sand is blank times the amount of green sand. Now, look at all of these. The amount of yellow sand is always the same. No matter how we named it, it's always the same. How many times yellow sand is how many times the green sand? Well, it's got to be less than 1 because the yellow is less than the green. So this is where we are kind of like multiplying by fractions gives us a smaller number. So the amount of yellow sand is 3/4 as much as the green sand because it has 3 compared to the green has 4. So it's 3/4 times. It's like 3/4 of a group of the green sand. That's why we call it multiplicative comparison because it has that word times. It's 3/4 of a time or 3/4 times the green sand. What about the amount of green sand is blank times the amount of yellow sand? Well, the green sand is blank times the amount of yellow sand. So we know the yellow sand has 3. The green has more than that. If we're talking about the yellow sand being like the whole thing, in this case, here it is. Here's the yellow sand being the whole thing. It's 1 1/3 times. Look at this. 1 1/3 times. See how that matches up? The last one, we said the yellow sand was 3/4 times the green. Look at that. That's why they want us to change the size of the hole to talk about which one is the whole. If the green sand is the whole, it's 1 cup. The yellow sand is 3/4 times that because it's smaller. If the yellow sand is the whole, they tell us to talk about that the green sand is 1 1/3 times as much because it's more. So the number has to be more than one because if this is the whole, this is more than that. So it's 1 1/3 times. What about the total amount of mixture is blank times the amount of green sand? The total amount of mixture is 7. How many times is it bigger? Well, the green sand is 4/7 times of the whole mixture. All right. The last thing they want us to really think about is what if we wanted to put these into sort of an algebraic expression? Thinking back to the unit that we just finished, we wanted to name these as variables so we could change them in any way and still have it work. So, what we're going to do is just take all of the greens and we're going to call it G. And we're going to take all the yellows and call it Y. So, G for green, Y for yellow. So then the ratio, we could change the ratio if we didn't like the ratio 4:3. If we mixed it together and said, that doesn't actually make a really nice color. That's not what I want. That's not the mix I want. I want to do 5:2, or I want to do 10:4, or whatever it would be. You can change that because you're calling the amount of green, you're calling it G, and the amount of yellow, we're going to call it Y. So what would that be like if we were going to write that as a proportion? Well, right now we have a 4:3, but we could also call it G to Y. G to Y. And that way we could change the numbers in here and still know how to work with that because it would be G to Y, green to yellow. Now, if we wanted to relate these quantities to each other in another way, again, using letters, we could talk about that Y, there's the Y is all the yellow, Y is equal to, what is it equal to? It's equal to 3/4 of G. G has 4 parts, Y has 3, so it's 3/4 of G. So when we hear 3/4 of G, what does of mean in math? Think of groups of. Means multiplication. So 3/4 times G. 3/4 of a group of G. Do you agree with that? Y, all the yellows, equals 3/4 of a group of G. It works, doesn't it? And when we hear of, when you're doing math and you hear of, right away your mind should be thinking, I wonder if that means groups of. I wonder if that means multiplication. You should always have that in your mind as a question. But what if we want to talk about G? G, the green, G equals 4/3 of Y. So G is more than Y. So it's 4/3 of a group of Y. Now remember, when you're writing numbers and letters together, you can include a multiplication sign, but you don't have to. You could just squish them right together. It's 4/3 G. And that's how we read it, actually, 4/3 G. But it really means 4/3 of a group of G. I hope this was helpful for you. Feel free to stop the videos always at any time and go back and watch them if you need it. Good luck. See you next time.